Welcome again to Wickerson Studios in an attempt to move into coordinates and graphs, which I think will be much more exciting when we get into some simple linear line and curve geometries. I just wanted to spend a little moment here on the absolute value and put into this large script, which I'll be sharing on GitHub, maybe through my Patreon membership, a little bit on absolute value. So you think you have it represented by these straight bars, which will say that if x is greater than or equal to 0, then the absolute value is set to x, and if x is less than 0, then it's still set to x, and that's basically it. The geometry is geometrically x is represented as a non-negative distance from x to 0, and there's a more general formula here where you can deal with x minus y, and you can think about that conceptually on the real line, which is basically what I was looking at before. So what is that? It's basically the distance between x and 0, or x the distance between the points x and y on the real number line, which is something that we've made a model of before. The only thing I wanted to do here is there's a couple of properties that you can look into that are the proof through the triangle inequality, but basically I re-pulled out this old script on the falling rock, which is this parametric model here, which allowed me to move that ball off in the shape of a vector and affected by gravity. And, in my initial ideas, I thought, well, I'll just take that and make sure it never drops below 0. Now, the problem with that script is obvious. It keeps accelerating as if it's falling down as it turns around and comes up. But that's just something just to show the power of the absolute value. It won't allow it to bounce below. Now, of course, it doesn't behave like it's a secondary bounce. You'd have to do some more physics and formula in that. But I thought that would be a nice example. I did throw it into a much more articulated line from 48. I changed it. So whenever I put things in red, it's usually warning it's not working, but also I'm putting any changes there in red as well. And then I brought the degree down to a polyline because it wasn't necessary to write it. And why I did that was the finesse. As I bring this down, you'll watch what happens as this bounces. The line actually jitters a bit. You see the polyline right there has this right at that base, this little tiny bend, because it's trying to interpolate a curve. But it's not trying to interpolate a curve, it's trying to build a polyline. If I put it through interpolation and bump this up to 2, 3, or bigger finesse, it's going to have this wiggle wobble and this kind of NURBS effect on that curve. But it is a very simple simulation using the old script and getting you thinking, what does it mean to have absolute value? Well, it just doesn't allow that point. And technically the ball hits, but the center of the ball never hits. So, you're dealing in simulations, not the real world. Now, that's it. I'm not going to do a big tutorial of this. I've done it before in the motion of the falling rock. And like I said, all I did was go in here and change the steps within the range to a little more. Affecting all of the ranges into the point system, which was then made into the interpolated curves, which I set the degree down so they became polylines again. So once you get good at this, you don't have to let everybody know every detail what your script's doing, but you should be able to break it down in a sense that those were polylines, and I could swap those out instead of degree 1 curves. I could pull in the polyline curve and swap that out for any one of those if I wanted as well. Anyway, that's it. I am excited to move on. I want to really push through, and I want to get into coordinates and graphs. And what I'm going to do at this point before I get into this, which is going to move beyond the Rhino points, lines, and curves into the circle and the ellipses and hyperbolas and all these wonderful things, is I'm going to take this master script here and start bringing it out as in the calculus script on my GitHub for anybody that's interested. And I might put it into my tier 1 $3 membership on Patreon just to see who's really got the bug for this type of stuff. And any of my current Patreons, I'll give them the invitation to that script. After a month or so, I'll probably just make this public as well. So thanks very much for watching.